5 real mysteries scientists still can't explain. What if the universe shouldn't exist? Seriously, according to everything we know, the Big Bang should have created equal amounts of matter and antimatter. When those two meet, they annihilate each other, leaving nothing but a flash of light. If that balance had been perfect, our cosmos should have blinked out of existence the moment it was born. And yet, here we are. That incredible fact is just one of the profound puzzles that has even the top scientific minds scratching their heads. From the weirdness of the quantum world to invisible forces that shape the entire cosmos, we're exploring 5 real mysteries that are pushing the absolute limits of what we know. Section 1. The matter-antimatter imbalance. So why did matter win? The mystery comes down to something called CP violation. In simple terms, it means the laws of physics don't apply equally to matter and its antimatter twin. Recent experiments at CERN have confirmed this in a huge way. Scientists at the Large Hadron Collider Beauty experiment observed that certain particles called baryons, the building blocks of you and me, decay differently than their antibaryon counterparts. They found a small but crucial asymmetry, and the result was so strong that it had a statistical significance of 5.2 sigma. That means there's only about a 1 in 10 million chance that this is a random fluke. This tiny imbalance might be why for every billion matter-antimatter pairs that wiped each other out, one extra matter particle was left to build everything. But here's the catch. While this is a massive discovery, the asymmetry we've measured isn't nearly enough to explain all the matter in the universe. There has to be some other unknown physics out there, a missing piece of the puzzle that saved our universe from disappearing. Section 2. The muon anomaly. Imagine you have a tiny spinning top that wobbles. Now imagine it wobbles just a little bit faster than your best theories predict. For years, that was the situation with a particle called the muon. Muons are like super heavy cousins of the electron, and they have a tiny internal magnet that wobbles in a magnetic field. Physicists can calculate this wobble with incredible precision using the standard model of particle physics. For a long time, experiments showed muons wobbled faster than predicted, a hint that unknown particles or forces were nudging them along. But the plot has thickened. The final results from the muon G2 experiment at Fermilab, announced in June 2025, measured the wobble with a record-breaking precision of 127 parts per billion. At the same time, theoretical calculations have gotten much better. While a gap between theory and experiment still exists, it has narrowed significantly. What was once a strong hint of new physics is now a tense, hotly debated puzzle that reinforces just how much we still have to learn about the fundamental rules of reality. Section 3. Dark matter and dark energy. Everything you can see, every star, every planet, makes up only 5% of the known universe. The other 95% is made of 2 invisible components we know almost nothing about: dark matter and dark energy. Dark matter accounts for about 27% of the cosmos. We know it's there because we see its gravity in action. It's the invisible cosmic glue holding galaxies together and keeping them from flying apart. But it doesn't interact with light at all, making it completely invisible. The rest, about 68%, is dark energy. This is the mysterious force that's causing the universe to expand at an accelerating rate. For a long time, scientists thought this force was constant, but the story might be changing. Recent data from the Dark Energy Spectroscopic Instrument, DESI, has created the largest 3D map of the universe ever. When combined with other observations, these results show hints that dark energy's influence might be weakening over time. If these hints are confirmed, it could mean the standard model of cosmology needs a major update. We don't know what either of these cosmic components truly is, meaning we're fundamentally missing 95% of the picture. By the way, if you're finding these cosmic puzzles as mind-bending as we do us a quick favor and hit that subscribe button. It helps us keep digging into the universe's biggest questions. Section 4. Fast radio. Bursts. Picture a blast of energy so powerful it unleashes more energy in a millisecond than our sun does in a year. These are fast radio bursts, or FRBS, and they are one of the greatest enigmas in astrophysics. These intense pulses of radio waves flash from distant galaxies, and we have no solid idea what causes them. Theories have bounced between supermagnetic dead stars called magnetars and even signals from alien civilizations. The puzzle gets deeper because some FRBS repeat while others are one-off events. Just when it seems we have a suspect, a new clue throws a wrench in the works. For instance, an event named FRB 202, 2102, 2a, was traced back to the chaotic magnetic field right around a neutron star, which supports the magnetar theory. But then another burst, FRB 202-40209a, was found coming from the outskirts of an ancient 11.3 billion-year-old dead galaxy, where the types of stars thought to create magnetars shouldn't even exist. Every new discovery seems to contradict the last, keeping the true source of these cosmic flashes a profound secret. Section 5. The origin of cosmic magnetic fields. Magnetic fields are everywhere. I'm not just talking about your refrigerator magnets, but fields that stretch across entire galaxies and the vast, empty voids of space. They are immensely powerful, yet their origin is a fundamental mystery. Scientists have a good idea of how turbulence can amplify existing magnetic fields through a dynamo process. It's like we know how to turn a small spark into a big fire. The problem is, where did the first seed fields come from? We have no clue. Some theories propose these seeds were forged moments after the Big Bang. Others suggest they were created much later by the first stars or by jets shooting out of the first black holes. Researchers are exploring everything from plasma instabilities to supernova explosions as possible sources. But for now, we lack a complete theory that explains how the universe first got magnetized, from the smallest scales to the largest. So from a universe that shouldn't exist, to particles that refuse to follow our rules, and invisible forces that shape everything, it's obvious we are just scratching the surface of reality. These mysteries aren't failures of science, they are the frontier. They show us that the more we learn, the more we realize how much is left to discover. And that's the beauty of it. Every answer just leads to an even better, more profound question. Which of these mysteries blows your mind the most? Let us know in the comments below. And if you want to explore more of the universe's biggest questions, be sure to subscribe. Thanks for watching.